4.2, properties of rational functions. So today is really just, let's look at this equation that we're given and let's analyze it. And we're only going to focus on examples 1 through 3 in this video. The next video will be the rest of this section. What is important with this section is you're going to need to be very confident and comfortable with analyzing this function, because in 4.3, we graph them. So you're going to have to be able to find all of this stuff in order to create an accurate graph. So finding the domain, that is not new. We have been finding the domain of functions for a very long time. We need to remember domain is stating what makes the function undefined. What values are x allowed to be? And in a rational function, your domain is going to be centered around the denominator. Your denominator cannot equal 0. So we need to find what values make this undefined. So for my domain, I'm going to take my denominator and I'm going to set it equal to 0. I need to find what makes this 0. So x minus 2 equals 0, which gives me 2. X plus 4 equals 0, which gives me negative 4. So my domain is x such that x cannot equal negative 4 or 2. It can equal anything else but negative 4 and 2. Sorry, I forgot to write the negative 4 on that. Now, your vertical asymptotes are going to come from your domain. So your domain comes from the denominator, and your vertical asymptotes also come from the denominator. So we put vertical asymptotes in this spot of what makes the function undefined because your graph will not cross there. So asymptotes are those barriers. So our vertical asymptotes come from your domain, and they are equations. They're the equations that you actually came up with. So x equals 2 and x equals negative 4. And then your intercepts. I don't want to spend a lot of time on these intercepts because we should be able to find an x-intercept and a y-intercept. So the x-intercept happens when you make y equal to 0. So if I make y equal to 0, I have negative 4x squared over x minus 2, and then I write a 4, x minus 2, x plus 4. Now I don't want that fraction. So when I multiply by 0, that's just going to go away, and I'm left with 0 equals negative 4x squared. So a nice little shortcut here is your denominator is always going to go away. So your x actually comes from the numerator. So here I go through, do the math, and x equals 0. So my x-intercept is at 0, 0. Now I'm going to find my y-intercept. Y-intercept happens when you make x equal to 0. So y is going to equal negative 4 times 0 squared, 0 minus 2, 0 plus 4. This is 0 over negative 8, but it's still 0. So my y-intercept is also 0, 0. So that was quick, but this isn't something that should take you guys an extreme amount of time. It should be quick. So I'm going to go through the same process in this next one, but I really do need to factor first, you guys. You want to factor, and then you want to cancel whatever you can, because those will be values that will not exist in your graph. So this the top, the numerator, has already been factored. So I have my negative x and 1 minus x. Now the denominator I can factor. So I have 3x and x. When I break apart 3x squared, and then 2 is 2 and 1. But I need to place them, so I get a 5. So 2 and 1. And nothing is going to cancel here. So I'm not going to have to worry about that. I could just jump right into domain, vertical asymptotes, and x and y intercepts. So my domain comes when you set the denominator equal to 0. And then I'm going to look at each of my factors. So this is 3x plus 2 equals 0, which is negative 2 over 3. You guys can do the math on your own. And this is negative 1. So this will be x such that x cannot equal negative 1 and negative 2/3, which are also your vertical asymptotes. So your vertical asymptotes are negative 2/3, because we have to block our graph from going there, and negative 1. Your x-intercept, don't forget, that comes from just the numerator. So negative x, 1 minus x equals 0. Set both parts equal to 0. Negative x equals 0, which is 0. And 1 minus x equals 0. When I move the x over, you get 1. You're probably thinking, holy cow, she's going really fast through this. That's fine, because you can pause this, you can rewind it, you can rewatch it, but I'm doing review here, you guys. I am not doing anything brand new right now. And then the y-intercept, you make all your x's 0, negative 0 times 1 minus 0, and 3 times 0 squared, plus 5 times 0, plus 2. Well, I should be able to stop, because as soon as you see that 0 out front, this numerator is going to be 0, the denominator is going to be 2, which is 0. So I have a y-intercept of 0, 0. You got to be quick, you got to be efficient with these, because when we start graphing these, this is just a little piece of what you guys are going to have to do. And you will have questions like this on your quiz that is coming up. You are going to have some questions where you have to find the domain. You have 2 questions, in fact, where you have to find the domain. 1 and 2 involve the domain. So hopefully you guys will be able to do that. Number 6 is going to involve finding the vertical asymptotes. You are going to have to be able to do that. So is number 7. Sorry, you guys, I'm running out of room here. So 7 and 6 are vertical asymptotes. 1 and 2 are domain. And for the intercepts, you're going to have 11 and 12. So you have a lot that you guys are going to have to do with looking at these, and you're going to want to be quick. You're not going to want to lag on these. Again, this is review. Hopefully that makes sense. Now you're going to have to do this exact same stuff from a graph, but we're going to also now throw in the range, horizontal asymptotes, which are going to run left to right, and oblique asymptotes, which are going to run at a diagonal. So let's see here. I'm given the graph. Domain and range should be relatively easy. So my domain, x such that x cannot equal. Well, let's see. I have a vertical asymptote, so my graph is not going to touch 0. My range. And look in the notes. It said domain, vertical asymptote, range, horizontal asymptote. Now, here we don't have a horizontal asymptote. And if you look at this graph, it's continuous vertically. So it's going to go up and it's going to go down, which makes this all reals. Intercepts, that should be easy. I'm not even going to identify which is which. Let me put my graph back in here. So I have negative 1, 0. I have 1, 0, and that's it. And horizontal asymptotes, so I'm going to call that my hat. There is none. There are no horizontal asymptotes. They would be running left to right. Vertical asymptote, I found that when I did the domain. Your vertical asymptote was at 0, so you write it as an equation, x equals 0. And then the oblique asymptote runs at a diagonal. So here is my vertical asymptote. See how this red dashed line is at a diagonal? That is your oat. And that equation is going to be rewritten into y equals mx plus b. So I need my slope, and I'm going up 2 over 1. So this is 2x, and I'm starting at 0. And you don't need that 0 there, but for note's sake, I'm going to put the 0 there. So that's everything you have to do to analyze from a graph. Now I'm going to move on to 27. Questions, make sure you're writing them down. So I'm going to start with the domain. Again, domain is stating what x cannot equal, and that happens from your vertical asymptotes. So here I have a vertical asymptote at -2, and I have another one at 2. So those are the two places x cannot equal, that x cannot be defined. So those are undefined values. Now our range is tricky. If I look at the bottom, this is going down to -infinity, so I'm going to start with that. But when I follow this graph up, it gets to 0. So it's going to stop at 0. Then I see a gap. And then where's my asymptote? This horizontal asymptote is at 1. So that's where it's going to pick back up, is at 1. We have a gap here, and I'll show you with the highlighter. There is a gap here. There's no graph there. So now, where is this going to finish? They go up to infinity. That's a parenthesis, just an ugly looking one. Now I want to talk about why 1 has a parenthesis. It's never going to touch 1. There's an asymptote there. So it's not going to touch parenthesis. Now I'm ready to do my my intercepts. So my intercepts, let's see, I have a 0, 0. And then it says horizontal asymptote that I need to find. Horizontal asymptote, here's my horizontal asymptote, y equals 1. Vertical asymptote, there were 2. X equaled -2 and x equaled 2. And the oblique, there are none at a diagonal. So none. Shouldn't take you guys long to go through and do these on your classwork. They're relatively simple. Just pay attention to what you're doing, please. And questions, make sure you write them down. Now, this last example is about graphing, and we're going to look at parent functions first. Sorry, let me get this at the right spot. So we have two types of rational functions. We have rational functions which have an x in the denominator. So no matter what I plug in, it is going to be a fraction. Unless I plug in a fraction, then it will be a whole number. If I plug in a positive, it will remain positive, which is why it stays in the first quadrant, bounded by two asymptotes, because your denominator cannot equal 0. In this third quadrant over here, if I plug in a negative number for x, it will always be negative. So it will be in the third quadrant. I plug in a negative, I get a negative. Unless I already have a negative, then they do reflect over the x-axis. Now when I'm looking at this second parent function, when there's an x squared in the denominator, that square makes everything positive. So no matter what was down here in the first one will be up in the second one, because there will be no negatives. Unless there's a negative already a part of the function, and then it drops everything down. So for today, you guys are only going to graph these based off of transformations. So you don't have to do a lot of extra stuff with them. Please remember what your transformations are. That if you have a value inside, so in this case, it's going to be with the x in the denominator, you are going to move your graph left or right. And your vertical asymptote will switch. If you're moving to the left, 7, your vertical asymptote will be at 7. If you're moving to the right, 4, your vertical asymptote will be at the right 4. If your value is, so we're used to saying, oh, it's outside. In this case, it will be by itself, a constant completely by itself. That will move your graph up and down. And with that one, the horizontal asymptote will move with it. And then a negative will flip your graph upside down. So you are going to have a graph that you will have to do with transformations, and that is number 5 on your quiz. So let's go over these 3 that I have here for you. So I see this 3, which is all by itself, so that means the graph is going to go up 3. And since I see a square in the denominator, my graph is going to do something like this. So I'm going to make my coordinate plane. Okay, it's a very small coordinate plane. It'll work. And I know since I'm going up 3, if I look up here back at my notes, let's see. Outside by itself, it's going to go up or down, and I move the horizontal asymptote. So my horizontal asymptote was at 0. So now my horizontal asymptote is going to be at 3. I don't know why my coordinate plane's like that. So my horizontal asymptote is at 0. My vertical is still at 0. That does not change. And I'm just going to do a rough sketch, you guys. This is so bad, but I'm just going to do a rough sketch. I know what the graph is supposed to generally look like. So for time's sake, I'm just going to make my graph look like the parent graph that has been shifted up 3. This actually should be, let me make this more accurate. That should be right there. And let me make this one more accurate. It should be right there. Because it was at 1, 1 and negative 1, 1. So that shifted up 3 with it. So there's that graph. This next graph in 31, transformations make this really easy. I see that square. Since I see a square and I don't have a negative out front, it's going to do something like that again. But this number tells me I'm going to go right 1. I got to change the sign. What makes it 0? Positive 1. So I go right 1. So let me make another coordinate plane. I'm ready to put in my asymptotes. So right 1, my vertical asymptote is the asymptote that's going to move. So my horizontal stays and my vertical is now moved. So I need to look back. I'm going to look back up here. These were at 1, 1 and negative 1, 1. Those have shifted. So I'm going to come back here. It was at 1, 1, but it went to the right one. And then the other one will be right there with it. And then you just make your rough sketch. Now I'm ready to do the next one. And this one, there is no exponent. So that one is going to be the one where they're in opposite quadrants. This tells me I'm going to go up 1. And this one tells me I'm going to go right 1. Make my coordinate plane. I'm ready to graph this. So this is an up 1. So my horizontal asymptote is now at 1. A right 1. So my vertical asymptote is now right 1. And then again, the point would have been at 1, 1. So I have to move it up 1, right 1. And then here's the other one that goes with it. So there is some symmetry to these. These shouldn't be too bad for you guys to graph. Again, you guys have done the analysis. You guys have done the transformations with other graphs, other functions. So we're just applying the same stuff to a different function, but the idea is still the same. But if you still have questions after this, please make sure you write them down and ask me in class tomorrow for anything that needs extra clarification.